Okay, so let's get started for today. Today, what we are going to discuss? Today, I'm going to discuss about Docker. So let's discuss Docker. So, do you have any idea about Docker? Before that, you asked for something, right? Policy generator. How do we generate the policy, right?
Yes, yes.
Yes.
AWS policy generator. Yeah.
You're in sparing your screen at them.
Sharing the screen.
Let me share my screen. I hope my screen is visible now.
Yes, yeah.
Right. So AWS policy generator, this is a website. Here you can go and generate the policy. So I don't know why the internet is so.
So it's by AWS again, is
Yeah.
it? AWS wants this platform.
Yeah, it's AWS policy generator. Whom you want to generate? What policy you want to generate? Let's say I want to generate IAM policy, right? So I want allow or
Yeah.
deny. You want to allow or deny, two effects are there. So let me see allow and to which service. So let's say I want to do for S3, right? So I selected S3. What actions for S3 you have to select? Let's say what actions for S3, list bucket, list all my buckets, list buckets, uh, object, put object. These are all the permissions. Delete object, put object. Put means upload the object. You will be able to upload the object. Put object, put object, then get object, get object, get object, then delete object. So get object, list object. Yeah. Yeah. So these are the permissions which I selected. List all my buckets, list bucket, delete object, create bucket, create bucket, then list bucket, list bucket, list all my buckets. Yeah, list bucket is selected. So these are the permissions. So I selected to which resources. Let's say all AWS resources. You want a specific resource, you can select a specific resource. So I want for all, then generate policy. So you have to add the statement, then generate the policy. Policy generated. Can you see this?
This is what we took from ChatGPT. We didn't know. This is JSON, right?
Yeah, it is JSON. So now you will copy this and you will paste
Okay.
it.
Got it. Got it.
So you don't need to go to ChatGPT. You can just come to this policy generator and you can get the generate. You can generate your policy from here.
Got it. Got it.
And you will copy this. You will go over there and you will paste it. This is how you can generate your policy. Now let's get back.
Yes.
Let's get back to Docker. So I hope you watched some videos on Docker, right?
Yeah, we understood what Docker exactly is. See, Docker, it helps develop, building, and running and sharing applications. So anywhere in a containerized environment,
Okay,
it is a container tool.
you're right. You're right. So Docker, it's a containerization tool. So why do we need container? Why do we need container?
So it is a package of, for example, if you have to do something, I mean, a software developer has to do something. First, he has to push codes. Then he has to push. So if he has to install, he has to install the installers. Later, even he has to use the pushing application. So he has to install all 3 to 4 tools and platforms to uh, create a container. Well, sorry,
Mm-hmm.
not to create a container, but yeah, install everything to deploy or do something,
Mm-hmm.
build an
So,
application. But what container does is it has all this in one. So
mm-hmm.
basically, it is a package of all pushing installations and codes in one box, in one application.
Okay. So before that, I just want to like, I'll be uploading this video on YouTube. It's, is it fine for you if I upload?
Yeah, yeah, yeah. Yeah.
Because
That's fine.
yeah, your image is there. That's why I just asked you before putting
That's
it.
okay. That's okay. That's good.
Right.
That's okay.
Yeah. Super. Right. Fine. Um, so now you said we have to push and we have to pack and all of this stuffs, right? If okay, before containers, how the applications are developed and deployed, any idea? Have you ever tried deploying an application or creating an application?
No,
Okay,
but I have an idea. Yeah,
how to develop
how
an application?
application is created.
Yeah, how to
Yeah.
develop an application?
First, what a backend developer will do is he will write codes
Mm-hmm.
to build an application.
Mm-hmm.
After he writes the specific codes and application is built, it will be sent to the front end developer where it will be, after all the API work is done, it will be sent to the front end developer for the uh, screening point. Yeah, something called, yeah, screening will happen.
Mm-hmm.
By the screening is developed by front end developer. Later, it will be tested and deployed.
See, first we'll write the code, then we'll build it.
Yeah.
Building in the sense creating a package. We build it, then we test it. While it is building, so you have to make sure all the dependencies or libraries, everything. So everything needed to run an application. So everything needed to run an application. Everything to run an app. To run an app is packed as a container. Is packed as a container. Then without container, how do we deploy an application? Without container, we deploy an application directly on servers. Let me tell you how it works. So first of all, we create a server. You know about servers, right? You learned
Yes,
AWS,
yes.
EC2, right?
EC2. Yeah.
Yes. So you create a server. Now let's say it is a server. I would say, okay, this is a server. This is a server. This is a server. In this server, so you will be having an operating system, right? OS. So on top of OS, you install some binaries, right? And you get the source code. On top of source code, you get the dependencies. You do all the configurations needed to run the applications and everything. So this is manual. So first you will get the OS, then you install all the Java, Python, whatever needed. Let's say it's a Java application, you have to install Java. If it is a Python application, you have to install Python. Let's say Java 17, you have to install Java 17. Then you will get the source code. How do you do? Git clone or something you will do. So you get the source code, then you install the dependencies, plugins, whatever needed. Then you will do all the configurations to run this application. This will take efforts and time. Am I correct?
Yes, it's
Efforts and time. So to reduce this, you see now this application, it may not run as we expect on every device. Or so in development, you know that in companies, we'll be having different environments. Do you have any idea about the environments? Do you have any idea about the environments?
not.
No idea.
What types of environments?
So I'm going to explain now. See, application is developed in dev environment,
Yeah.
right? So why do we call it as environment? Why it is called as an environment or environment? Why do we call it as an environment? How? Because here we have everything to develop the application. So we have everything. So what and all we have? So we have servers or devices, servers or computers. We have all the tools, we have all the configuration, everything is set up, we have all the DBs, if any, we have everything to develop an application. Your Git, GitHub, repositories, and everything set up here. This is dev environment. So why do we use this dev environment? Why this dev environment? To develop
Develop an
an app,
application.
right? An app.
Yeah.
This is complete separate setup. So here servers will be there, tools will be there, configurations, everything, and network. So network where servers can communicate, network and everything and anything, whatever needed to develop an application, everything is configured. That is why it is called as an environment, right? So if it is it can be a Kubernetes cluster, it can be a group of servers with all the necessary components needed. Everything is set up here. Now developers, they develop the application in dev environment, right? So you will log into dev environment using your laptop. It can be a server, it can be a cluster. You will log into that, then you develop the application. Once the application is developed in the dev environment, here developers are involved. Who is involved? The developers are involved. Next, this will go to testing environment. So you know about
Testing
testing, right?
environment. Yeah. Yes. Yes.
This will go to testing environment. So test, or we'll call it as UAT, test environment, or UAT, right? So in test environment also we will have all the tools, all the servers, database, configurations, network, everything needed to what? To test an application. To test an application, whatever needed. So here also we need servers, we need tools and everything to be installed to test an application, right? To test an application, everything needed is configured where? In testing environment. This can be a group of servers, it can be a Kubernetes cluster, it can be your Azure App Services or Azure VM, it can be EC2 servers with some networking configurations, and everything is set up here. You just have to install your application into test environment, then you will get a domain name or you will get an IP address. You can test your application. Who will do the testing? Who will do the testing?
Test engineer.
Test engineers,
Test engineer.
automation test engineers, manual test engineers, SDET. Yeah, these guys will do the testing, right? Then we have which environment? Then which environment comes?
On deployment.
Operational.
Operational. Production environment. Prod.
Production environment. Yeah.
So production, and what is this production environment? So wherein the end users, they will access your application. This is prod. So this is production. So prod environment. So now here everything is set up to run an application. So end users can use your application, like what are the servers needed, the cluster needed, the databases, tools to be installed, configurations, everything is set up here in the production environment. From this is where the customers, they access the application. Let's say it is a Flipkart application. Flipkart, once it is deployed in the production, so once it is deployed in the productions, the users will be able to use this application, right? Now in between we have something called staging environment, pre-production environment, like majorly dev, test and production. So if you want one more layer of environment, so you will get something called staging environment or pre-production environment, just to make sure it is an identical environment. It is an identical environment to production. Exactly same configurations will be done like production. Before deploying your application into production, first we will push it into pre-production, then we'll push it. But major companies, they follow dev, test, production, and some companies, they will also have pre-production or staging environment. Easy, right? So why do we call it as environment? Because here everything will be set up to develop, test, and run the applications. Any confusions, any doubts here?
No, we're good.
You got it. Now your application is developed in dev environment, then which is being tested in testing environment, which is deployed into pre-production or staging environment. Later it is deployed into production environment, right? So it is changing the environment. And let's say developers, they developed in some other operating system, some other configurations. Now exactly same configuration should be done in the test to run your application. Exactly same should be configured in the production environment. Exactly same should be configured in the production environment. Then only your application runs as expected. Let's say Python 3.9 you installed in the dev, in the test you installed some other version. Do you think your application works exactly same?
No.
No. So now your application is platform dependent. That means your application only runs exactly same when all the configurations are same operating system, same configuration, same library, same tools, everything is exactly same. Then only it works same. And to set up, configure these, to run your application, it takes a lot of effort and time. So in early 2010, we introduced a new concept called containers. So now instead of doing all these configurations manually, what we are going to do, we are going to pack your source code, your configurations, the OS, and everything needed to run an application will be packed as a container. Are you understanding? Back then, we were configuring the servers, all the tools, configurations, dependencies, libraries, everything were installed manually. Now you don't need to install anything. You just have a server. Now you get an image, a container, just one command, docker run, or if it is a Kubernetes, just one command, your application will go live. Your application will run. How is this possible? Because we are going to pack everything needed to run an application. So what we are going to do, so we are going to pack everything needed to run an application as a package. So now what and all needed to run an application, tell me. So OS is needed, am I correct? Operating system.
Yeah.
Source code is needed.
Network.
Source code is
Source
needed.
code.
Dependencies are needed. If any libraries are needed. And if all the configurations, all the configuration setup, everything needed to run an application is packed. This is called as container. What is this called as? Container. Now how to create this container? Who will create this? A container can be created by a developer who developed the application. It can be created by a DevOps engineer, and it could be a shared responsibility. Then how to create this container? To create this container, we need containerization tools. So what do we need? We need containerization tool. So already you have heard something called Docker. Have you heard this?
Yeah.
Docker? Yes. This Docker, it's a containerization tool which will let us to pack an application as a container. How this Docker works, how do we create a container, we are going to discuss now. To create a container, first let's say you are going to build a house, correct? Let's say we are going to build a house. So everybody would like their own house, right? So this is a house, beautiful house. So we have multi. Okay, this is an old house. Let's say you want to build a new house with multiple floors, right? So let's say this is a house with multiple floors. This is the first floor. This is second floor, and ground floor is there. So let's say this is ground floor, and this is your balcony, right? So then here you have some helicopter helipad, and ground floor, and in the top floor there is one swimming pool and everything. So who will, what is this? This is a plan or a blueprint, correct?
Mm-hmm.
This is a plan or a blueprint. So now our container is like a house. Before building a house, so what do? You will go to an engineer. You will go to an engineer and you will get the blueprint. So what do we call it as? The blueprint.
It's a plan.
It's a plan or architecture design,
Yeah.
right?
Yeah.
Same way, first you should have a plan, right? So first you should have a plan. So this is the plan. Let's say. So this is the plan. Easy. So from this plan you will create a 3D. What you will create? A 3D diagram. You know 3D. You know 3D diagrams, right?
Yes.
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 So 3D
3D architecture.
architecture diagram.
Yeah.
From this 3D architecture diagram, once you finalize it, so what you are going to do?
We are going to start building.
Yes, that building you are going to build. So this is the building.
Yeah.
Building. Easy? Yes. So now this
Perfect.
plan,
Perfect.
this plan is called as Docker file. So what it is called as? Docker file. Here you
Docker
will
file.
write the requirements. Okay, I need this OS, I need this source code to be copied, I need this configuration, and everything you'll write it as a Docker file. Now using this Docker file you will build a 3D diagram. That is nothing but Docker image.
Image. Yeah.
It's like a blueprint, right? So from this Docker image you will build something called Docker container. Easy?
Yes. Yes. Yes.
This Docker file, Dayanand, Docker file will be a code or is it like a general words?
It's a text file. I don't say it as
Okay.
a code, it's a text file. But here you have some specific keywords that you have to specify. Let's say I want this operating system and all of this stuff. So when you write a Docker file, you will get to know. I'll show you how to write a Docker file, how to create image, and how to create the containers. Right now, how internally Docker works to create these containers. Right. So now you understand what is container. You understanding the pain point. Could you define or could you tell me why do we go for container? Why do we go for container? Very easy question. Already I discussed the problem.
We need not to have multiple environment. We can keep in one single
No,
thing.
we will have a multiple
It's a
environment. We'll have multiple
Since
environments. So there is nothing change in the environment.
it's a package of tools instead of
Package of
coding.
package of tools. Is it correct?
So yeah, I not tools exactly. So instead of coding creating OS, source code. Uh, so everything will be in one package. All this will be package, which is a container.
Okay. So why we go for containers? So basically, containers are portable. Do you agree?
Yeah.
So what is portable? Which runs on any machine,
Yes.
exactly
Yes.
same. Portable. Then,
Can be transferred to one system to another. Still, it works the same.
so containers are lightweight because I will discuss the architecture of containers, so you will get to know why it is lightweight. Containers are lightweight compared to VMs. They are very lightweight. Okay. Then they are faster, runs faster, and easy to create. So these are the reasons why we go for containers. Are you understanding?
Since it is lightweight, it will be
It runs
it will not
faster.
consume much storage, and yeah, since it is not consuming much storage, it is running faster, and
Right.
yeah, it is easy to create. Yeah,
Easy to create and manage.
create. Yeah,
Right. So these are the reasons why we go for containers. So now
containers. Okay.
I said lightweight. Let's discuss why it is lightweight. See, let me show you servers. Now you know servers, right? What is a server? You know servers, right? What is a server? If I go to images, can you see this? This is a server. Can you see this? Is it visible? In our
It's
language,
not for me.
sorry.
Just a new. It's just a new tab.
Yeah, that's what. See, I'm just showing the image of the server. It's visible. This hardware
Okay, sir.
device.
Got it. Got it.
This is the
Yes.
server.
Yes.
Now you said you have built PCs, right? So in your language, what do you call it as? CPU, or
CPU.
correct, right? For
Yeah.
PCs,
Yeah.
it is a CPU.
Yes.
This is a server. It is a physical server. In early 1960s, 70s, in early days, we were running our applications on servers. Even today, many companies they run their servers on physical machines. Sorry, they run their applications on physical servers. Are you getting?
Um, so, for example, this Netflix is a server-based application.
Um, See, every application runs on server only, but whether it is a virtual
Yeah.
server, physical server, or it is running on container, that matters. That
Got
means
it. Got it.
we directly install the application on this physical machine. Now, this physical machine, so to understand this, you have to understand how the request is processed. Let's say this is your phone. What is this? Phone or laptop. You're searching for Instagram, right? So you open the Instagram application. How this request will be processed? Your request will be sent. So it goes on internet. So internet, go through internet. So here somewhere there will be a physical server. Okay. So there will be a physical server. This is a physical machine, a computing device. This is running an application which is Insta application, okay, Insta backend application. So your phone is a client, we'll call it as a client, and this is called as server. This is called as client server architecture. Do you know this? So your phone or a laptop
Yes.
which
Yes.
is sending a request is called as client, and the machine which is serving the request, which is serving through server. So you install Instagram in your phone. This is a different application which is Instagram client application, and there is another backend application, Instagram server application or backend application, which is running on the server. Now your Instagram application which is running on your phone will send the request to a server, an application which is running on the server. Now this application which will process your request and send send the response back. Are you understanding?
Yes, understood.
Understood? Now I am
Mm.
talking about this. This is a physical server, right? How you are able to reach the physical server? So you are able to reach the physical server through internet. So what is internet? So you every day we use internet, right? These are a basic concept, but which is mandatory to know. What is internet? Every day we use it, but we will never think what it is. Correct?
Yeah, it is a tool. It is something which we use to connect from our local system to the server.
No. Let me tell you one thing. See, internet, it is nothing but a large network of computers, right? So every device in the world, every device, your device, my device, each and every device which is connected to internet, which is using the internet, we are all working in the same network. That means, let's say we are all working in the same office. Now if you are working in the same office, if I say Dikshita, in the same office, you know who is Dikshita, correct? Why? Or let's say same family, let's
Yes,
not
yes.
talk about same office, let's say same family. In Dikshita family, if somebody says Dikshita, everybody knows who is Dikshita. Am I correct?
Yes.
Mm.
Why? Because Dikshita has her own unique name, that is Dikshita, and you have your own name, and I have my own name. In the same way, to connect all the devices in the world, all the devices are connected through cables, network. They are all connected through cables. The devices are connected through cables. Hey, Dhanand, how it is connected? How difficult it is to connect all the devices? Do you want to see? Do you want to see how devices are connected?
Yes,
Mm.
yes,
Azure. mm,
yes.
1 minute. Azure architecture. Azure global architecture. Global infrastructure. So let me show you how we are connected. Explore. So my internet is slow today. It is loading. Internet is slow. See, this is the world, right? We are all connected. So you can see these threads, right? These are the cables, you know, laid under the oceans. So you see, Earth is connected through cables. Can you see this?
Mm.
So
Yes, yes, yes.
these colors, these are the data centers. See these colors? Can you see these colors? These are the data centers. So I guess already you discussed what are data centers. Akshata would have discussed.
Yes,
Yes.
These are the data centers. Any request which goes through internet, which travels like this, which travels across the globe, and we reach. Now even whatever we are doing communication, which is going across, going through these cables only. Are you understanding? Now any request
Mm.
which you are sending, Okay, the request is being processed by another device which is working somewhere, in some location on a machine. That is what I just wanted to connect. You see, this is a machine. Now the complete world is connected in one network. That is nothing but internet. Easy.
Yeah.
Yeah, clear, clear.
Got it. So now your request will go through internet. Each and every device in the world, it has its own IP address, like your mobile number. So now your mobile number or my mobile number, which is completely unique across the globe. Am I correct?
Correct, correct.
Yes. Each and every device has its own IP address. It's like a mobile number for this server. Now, whenever you send a request, let's say you're sending a request to Instagram.com, this Instagram.com internally go to the server with some IP address, with some number. In the server, there is an application which is a backend application, which is a server application of Instagram. This will process your data, which will process your request, and it will send the response back to you. Now I was talking about this server. This is a physical server. This could be a virtual server. This could be a container. Now what is the difference between physical server, virtual server, and container? Do you want to understand what is the difference between physical server, virtual server, and container, or shall I directly start with container?
And let's learn that also.
Okay, that's fine. Physical server is nothing but this one. Which one? This one, right? We directly install our application into this physical server, and any request which is coming, which will come to this physical server, and this physical server, the application which is running on this physical server, will process the request, right? Why do we call this as a server? It's a computer, right? I can call it as a computer, or I can call it as a desktop. Why do I call it as a server? Why do I call it as a server? Do you have any idea about it? Vignesh?
It is called because
Why don't you call it as a laptop? My laptop,
laptop has the OS.
even server has OS. Only difference is the purpose, the use case. Laptop we will use for productivity. Maybe I can attend meeting, I can develop something, I can run an application, or I can do a lot of things here, right? Same way, servers are dedicatedly built for developing an application, running an application, processing the data, etc. etc. Are you understanding?
Okay. Yeah, yeah.
Yeah. So this are called as servers. This is a physical server. It's a physical device which is particularly developed for running an application, processing the data, streaming, whatever so tasks are there, right? So this is a server, physical server. Now on physical server, we, for isolation, let's say it's a physical server, we have a physical server. Let's say it's a physical server. So for isolation, we can divide this physical server and we can make multiple machines. Means to run multiple applications, multiple OS on the same physical device. Why do we want multiple operating systems or multiple applications to run? Because this physical server is a one machine. If I want isolation, how can I do isolation? Like, I can split this machine into multiple machines so that I can run multiple applications. So what I do, so this is the physical machine. See, this is a physical machine. I just divide this physical machine. So in physical machine, you will be having a hardware. On top of hardware, we'll install something called hypervisor. You know what is hypervisor? So hypervisor It is a software which will divide the physical machine to create virtual machines. So we will install hypervisor. On top of this hypervisor, now once you install the hypervisor, this hypervisor will divide your machine into different machines, right? So let's say I divided this machine into three virtual machines, right? I created three virtual machines. These virtual machines can have its own operating system. Let's say this same physical device, here Mac is running, Mac operating system, here Windows is running, here Linux is running, here some different app is running, app 1 is running, here app 2 is running, here app 3 is running. Completely isolated machines with the dedicated operating systems. Here let's say I have installed Java, here I have installed Python, here I have installed .NET. Completely isolated. Are you understanding? This is called as virtual machine. This is virtual machine. This is also a virtual machine. This is also virtual machine. Why it is virtual? Because all of these virtual machines are sharing the same physical device. Easy? Any doubts? Vignesh, Dikshita, any confusion, doubts?
No.
I'm good. I'm good.
Got it? So now you see there is one physical device. I created three virtual machines. You can create hundreds of virtual machines on the same physical device. That means this single physical device can run hundreds of virtual machines. This is the base concept of your virtualization. This is
At
where,
the same time, you mean?
yeah, at the same time, yes. Now, see, this single hardware device which has Linux operating system, which has Windows operating system, which has Mac operating system, you can run any operating system, any application. Everything is isolated. Now, this machine has no connection with this machine. This is VM1, VM2, VM3. VM1 is completely isolated, no connection with VM2. VM2 is completely isolated, no connection with VM3 and VM1 too. Are you understanding? Right? So
Yes.
whenever you request for an EC2 instance on AWS, you will get this one. Means you will get a small portion in a physical machine. On a physical machine, you will get a small portion of that machine. That is nothing but your VM. Every time you create a virtual machine, right? EC2 instance. How this EC2 instance is created in the background? There will be a big physical machine with now much more capacity. Let's say you requested for a virtual machine with 2 core CPU, 2 GB RAM, but physical device will have capacity like 200 core CPU, 200 GB RAM, and multiple terabytes of storage. Are you getting? A small portion of
Understood. Understood.
a small portion of a physical device is nothing but a virtual machine with a dedicated operating system, right? Now, a single physical machine is running hundreds of operating system, hundreds of different libraries, applications. So each and every virtual machine is heavy. Am I correct?
Yes. Yeah.
And you have to configure this virtual machine. You created AMI, correct? Amazon Machine Image. Did you create?
Yes. Yes. No, we when we created an instance, we configured it as per requirements. For example, storage, we gave it as the T2 micro, T2 nano, T3 micro, different types of storage for
Let's say now,
different types of
Okay.
let's say now you want
EC.
100 such machines with the different configurations. How much time it takes?
So if you have to create manually, you will have to create in case 100 times we'll have to create and configure it.
Okay, I will create somehow, let's say, I'll write some IAC code, maybe Terraform, and I will do it easily. Though you create the virtual machines, you have to configure the virtual machines. Within the virtual machines, you have to install and do all the stuffs. Okay,
Yes.
I will automate that also using configuration automation tools like Ansible and stuffs like that. Still, there are many things. Still, this virtual machine is heavy because it is running a dedicated operating system. So one physical machine is running 100 operating systems, which is always heavy on the physical machine. So from this virtual machine, we directly came to, so even today we use virtualization. I don't say we don't use. Yes, virtualization is the backbone. But now, instead of virtual machines, you see many people use the virtual machines, like 50% of the market, maybe more than that. I don't say that. But how this container works, what is the difference between virtual machine and container? You see, same physical hardware, or it can be a virtual machine. You have the hardware. So on top of it, you have the OS, operating system. On top of it, you have container engine,
Containers. Got it.
not container engine.
Engine.
Container engine you have, right? This container engine is nothing but your Docker. Now this,
You mean to say this container engine is the, for example, you told it's a plan.
it's not a plan, it's a tool.
Yeah, okay, the complete Docker tool.
Yes, it's a tool.
Okay.
It's complete Docker ecosystem. So now
Yeah.
this
Okay.
is the Docker engine is there. This Docker engine runs our applications as a containers. App 1, which is running, app 2, which is running, app 3, which is running, isolated. All are separated with a dedicated binaries or operating system, whatever needed. But here, one thing you have to observe very carefully, all containers are using same operating system. All are isolated.
Hmm.
All are isolated, but using the same operating. Since all the containers are using same operating system, same kernel, we would say. So this becomes lightweight compared to VMs. And to run this, now you see, these containers are packed. Everything is packed. You don't need to install anything. You don't need to install configure. Nothing to do. Just one command, Docker run. Your application is live. No need to create VM. No need to configure it. No need to get the source code. No need to manage the dependency. Nothing else. Easy.
Yeah. So then, as per my understanding,
Mm.
long story short here, what happens is on the left side, you can see no OS. Only, I mean, there are different OS. Then again, you will have to create an app or application. It might be a Java application, Python, or a .NET.
Mm.
But here, what happens when you install a Docker application on the right side?
Right.
Docker application runs on only one OS. So basically, one app, and instead of one level, Docker engine is installed. So this becomes lightweight.
You're right. You're right. All the containers are using the same OS. They are sharing the same resources, and these are all portable. These are all the containers runs exactly same on any machine. Only the requirement is you should have container runtime. I mean Docker. Only the requirement
Yeah,
is.
but when you install a Docker package, for example, like a Docker container engine,
Mm,
OS will be inbuilt.
your laptop OS is there, right? Server OS
Yeah,
is there.
yeah, laptop OS. So
Same will
that
be used.
when we install, okay, got it.
Got it. Same will be
So
used.
above OS, it is the Docker container, Docker application.
Yes, you're right.
Yeah.
Now let's say I want to run this as a, let's say this last application which is running on .NET, right? So same kernel will be used of this operating system, only the lightweight .NET environment will be packed. Lightweight .NET environment means enough resource to run the application, only lightweight things will be packed here, only enough resources, only the required resources will be packed as a container and which runs. Easy?
So when it comes, so if you want to run a .NET and you need a high scale application to run a .NET. So basically, what you do is you configure using Docker application, right?
Using Docker containers, yeah.
Whatever, yeah. As per your need, you will configure it.
Yeah, yeah. So going ahead,
So
you will get more idea about how things works. As of now, you
yeah,
just understand
what is Docker? Yeah.
what is
So
Docker.
Docker is basically it is like a Play Store. So where we can, it is an application where you can download multiple applications.
Mm, it is a tool where you can run containers. Means, yeah, that
Run
runs.
content.
Yeah,
Yeah. Okay. Got it.
right. So now, how Docker works? How Docker works? I said, if you want to create a container, first we'll create what? I think, yeah. First we'll create Docker file, then we'll create Docker image, and we'll create Docker container. How internally everything works in Docker. To understand that, we have to understand the Docker architecture. So what we have to understand? Docker
The architecture.
architecture. So let's understand Docker architecture. In Docker architecture, mainly there are three components. Can you see this?
Yes. Yes.
Yeah. So there are mainly three. Hold on. Yeah. So there are mainly three components. So first one is our Docker client. Oh, let me charge my laptop. Yeah. So can you see this?
Yes. Yes.
Yeah. So first is your Docker client. So what is this? Docker client. So this is Docker client. Docker client. Next you have Docker. Oh. Yeah, I hope the screen is visible. So Docker client.
Not that. Dhanam.
I hope now it is visible. It is visible. Is it?
Yeah. Yeah. Yeah.
Yeah. So Docker client, Docker host, and we have Docker hub, or we call it as a Docker registry. Docker registry, right? So usually this Docker client and Docker host will be on the same machine. So will be on the same machine. Docker Hub, it's like a GitHub for Docker containers. Are you understanding? So GitHub for Docker images. Sorry, GitHub for Docker images. So now Docker client, before running any container, right? The images, pre-built images. I told you, right? What is Docker file, image, and everything, right? So we keep the images here. Let's say it's an image of application 1, app 1. Okay, so this image is nothing but a blueprint. So this will be in Docker registry, nothing but Docker Hub, or it can be ECR Elastic Container Registry or Azure Container Registry, whatever it can be, right? This image is nothing but a blueprint to create the container. It's a blueprint, right? Who will create this blueprint, how to create this blueprint, that and all will come later. Now image is there in Docker Hub, that is nothing but GitHub for images. Easy? Any doubts here?
No.
No?
So already there will be pre-created image in the Docker Hub.
Yes. Yes.
Yeah.
Yes.
Okay.
So now this image is a blueprint to create the application. Where to create the application? To run this as a container. To create a container using this blueprint, first you should get this image into your Docker hoster. Where you should get your image back to Docker host. How to get it? If you want to get it, you have to run a command. The command is docker pull. What is the command? Docker
So Docker pull.
pull. It is a command. So when you run this command, here in Docker host, we have a daemon which is running. Okay. So daemon, Docker daemon. So DAEMON, Docker daemon which is running. So your request will go to Docker daemon. From Docker daemon, the request will go to Docker registry, that is Docker Hub, and the image which is here, which will be copied to where? Docker host.
Docker host.
Yes.
Yeah.
So now image is copied. How to create container out of it? If you want to create a container out of it, you have to run a command docker run and image name. So docker run and image name. Again, the request will go to Docker daemon, which is a background process. Then the request will go to this. It will check the image. So now image is there. So let me change the color of this so that you get the direction. Yes. Then from this, the container will be created. Easy?
Just a minute. So what happens when we run the command? So once we pull the image to the Docker host, what we do is we give a command called docker pull. Daemon sends a request to the Docker Hub, and the image comes to the Docker host.
Yes.
So later, what we do is we run a command called docker run. So again, it sends the request to the daemon. Daemon sends the request to Docker Hub. Docker Hub.
You need to send the image because already it is there, right? Image is already there. It's pulled.
Yeah, image is also. So what daemon does? Yeah, since image is already there, daemon will send a message to the Docker run. Then we will give the image name. So once we give the image name, daemon will identify, since we have given the image name, it is in the host environment itself. So it will run, it will send to the container bucket.
It will create a container.
Container, okay. It will create a container.
So it will create a container. Now this container is nothing but our app. It is
a package of all the tools we need.
Yeah, so everything needed is running as a container, right? So this is how internally Docker works, right? And how to build a Docker image, how to push our own images. That and all is there, Kahani. Going ahead, going forward, we will discuss that. Now, to quickly, I'll show you how you can install Docker desktop on your machine so that you can practice, you can explore this. What you can do, Go to browser and type docker install on Windows. So you will get
So if
docker
I'm
dist.
using Mac,
If
I'm
you're
using Mac, so
type docker
Docker
install
for
on
Mac.
Mac. Yes.
Uh,
So you get the website. You get the website. Go here. Go to this website and download desktop for Windows. If you're doing for Mac, then download for Mac. So I'll download this, then a package will be downloaded, then you run the package. So if it is a Windows, make sure that you need to have something called Hyper-V or WSL. So what is this? See, Docker initially developed for Linux machines, Linux-like machines. Okay, so in later time, in 2015, I guess, yeah, 2013 or 15, they released a Docker desktop. So Docker desktop, which runs on Linux type of machine, only Docker runs on Linux like machines, Linux similar to Linux machines. So we need a Linux environment. So how do I get the Linux environment in Windows? Either I can install Hyper-V or we can install WSL. WSL is nothing but Windows subsystem for Linux. It is Windows subsystem for Linux. Since Docker works on Linux machines, Linux type of machines, so we need some Linux environment to run Docker. So we need this WSL. Install WSL on your local machine first, then install this, download this, and run this. After all this setup, you have to restart your machine. Then you type here Docker. Already I have installed. You will get Docker desktop. So beautifully you get this Docker desktop. So let me take you. I think it will take some time to spin up. So, um, I guess it is stuck in the background. Sometimes it will go, it will stuck. Let me go to task manager.
so this is a lightweight app, right?
Yeah.
Yeah.
So now the Docker is just an engine which can run the container. So actually let me end this Docker. Sometimes it will go stuck in the background. So we have to come here and clear it. So then we have to spin up again. Yeah, so I cleared it in the background. So let me come back. Yeah, so you can see here under images, if I click on images, yeah, you can see there are many images. So you can see Docker Hub here. Docker Hub is nothing but a kind of GitHub for images. So you will click on Docker Hub, then you will search for the images. Let me click on Docker Hub. This is stuck actually.
So then the see images is already showing the I mean already pre-created images like a templates.
Yeah. Actually, I pulled that images last time. I was working on something.
Okay. Means okay, got it.
Yeah. So
So
now,
Docker Hub is a place where you pull the image and it will be stored in later part. It will be stored in images.
yeah. So now first you have to
Okay,
search
got
your
it, got
image.
it.
Let's say you want to run MySQL, the database you want to run. So already MySQL images will be there. So search MySQL. So you can see MySQL. Don't run directly the MySQL, which will not run. You have to do some configurations. So let's say you want to build Python. You want to run Python application. You can take this pre-built Python application. On top of it, you can add your source code. You can add all the configuration, and you can make your own image. This is called as base image. What is this? Base image. Okay, so this image is a
Okay.
lightweight image which just has the Python environment configured. Now on top of it you will add your source code, you do all the configuration stuffs, and you can create your own image. So let's say you are running a Java application. So Java, so let's say Java. So you can see you can run your Java applications from here. Easy. Or if you want to Java, we will not run Java, OpenJDK we have to run for Java. OpenJDK, yes, this is the image. OpenJDK for Java application. Let's say yours is .NET. So you can run .NET. See, .NET. So all the pre-configured images are there. These are base images. Just .NET you can't do anything. On top of it you have to configure, you have to get your source code, you have to do configurations and everything. Then you will make your own image. So this is the base image. By doing some customization to this base image, you will make your own image. That image will work. So this image, if you directly run, you get nothing. Are you understanding? So now,
Yeah, it's just a basic version. Later part, as per our needs, we are going to configure it.
yes, you're right. So now I'm going to run an image. This is an image, Nginx image. How to pull this image? I told you we can use commands, right? So no need to use the commands. Directly you can pull from Docker desktop, which is very handy for the developers, but not preferred for DevOps engineers. Usually we prefer running the commands, which is more easy and more flexible. So if you want to pull the image, click on this pull, and you can select different versions. These are all the different versions of Nginx. So you have, I think you discussed about Nginx in the last session with Akshata.
Yes.
It's a web server. Did you?
Sorry?
Did you discuss Nginx in the last session?
We just installed the Nginx on our terminal, updated it.
That's it. It is just
It's a static website.
it's a web server actually. Nginx is a web server.
Yeah.
It works as a proxy. It can also work as a load balancer, reverse proxy. It's a very powerful tool. Nginx. I pulled the image. You can see the images under this images. Can you see this? I click on images. Now you can see the image. Is it visible? Nginx image.
Yes, on the top.
I pulled
Yeah.
it from Docker Hub. Now it is there in under images. If you want to run container using this, click on run. Click on run. Go to optional settings. Here name your container. Let's say it's a demo container. I'll write it as a demo box. It's a container name. Then I'll show you something. Now, if you see this architectural diagram, if you see this diagram very carefully, so if you see this very carefully, you see I told you that this container is also a machine, right? this container is also kind of a small machine which is running on a physical machine or virtual machine. So now this is a machine. In this machine there are multiple small containers running. Are you understanding? These are containers which are running. Now you can't directly access this container or the application which is running on the container because this is running inside the container, right? So what you have to do, you have to map this container to your local machine. What you have to do, you have to map this container to local machine. This is called as port mapping. What is this called as? Port mapping. Any application which runs, okay, any application which runs on some port, let's say it is an HTTP which runs on port number 80, right? So let's say every application which runs on some port, if you are sending HTTPS request which is port number 443, if you are sending HTTP request port number 80, if you are sending SQL, if it is SQL, MySQL which runs on 3306, right? These are the different ports. Now you have to map, this is the container port. Nginx by default runs on port number 80. You have to map this port number 80 to your local machine. So let's say you can map to any number. So here also I will write 80. Okay. So what I am doing, I am mapping the container to my local machine so that I can access this website. So what I am going to do, so in Docker desktop, I hope you are understanding what I am doing.
Yes.
Yeah. So now you see container port is by default 80. Can you see this 80 TCP? Container port, it is by default 80. Now you have to map this into your local machine. Any port number you can select. Let me select port number 80 or let me select port number 90. Okay. So then click on run. So as of now we are not going to discuss about volumes and environment variables. So later we'll discuss. Port number 90, then click on run. So this will create a container. So let me click on left side. I'll click on container. So it will take some time to spin up a container. Yes, container is running. Do you want to allow public? Yes, allow. Yes. Right. Yeah, you can see this under containers. If I click on containers, you can see my container is running. So the container, there are many containers. Let me search demo. You see demo box. Can you see this? Which is running here. Can you see this?
Yes.
So now which is running on port number 90 of my local machine. If I click on this container, you can see this is the logs. Whenever any application which is running, which will produce some logs. Logs means what is running, who is accessing this application. Logs will be produced. These are the logs. And if you want to go inside the container, you can click on this exec. See, you can run Linux commands here. You learned Linux, right? You see, this is basically a small operating system within the container. Then you can see file system hierarchy. This is exactly like a machine, but a very lightweight machine. This container is also kind of machine, but a very lightweight machine. Then if you want to see the container statistics, you can see how much CPU it is using, how much memory it is using, disk read, write, bytes, network and everything, right? So you can get the logs. Now let me check whether my application is running or not. So this will take me to browser. See, it is coming here on the browser. So on the browser you can see my application is running. Can you see this? Welcome to Nginx. Visible?
Yes.
So this is the website. Okay, so now very small dummy application we are running. So like this you can run your Python application, Java, .NET, Golang, any type of application. We can pack it and we can run as a container. Now if I stop this container, this application will also stop. Can you see this? I just go back and restart this. Let me start it. You see, Log stopped. When I stopped it, log stopped. You see, signal went excited. Now it came back again. See, application is live. Are you understanding? Very simple. If you stop it, your application will stop. If you start it, it will start again. See?
So Docker is free for everyone, right?
Yeah, it's a free and
Well,
open
it's
source.
not.
Yeah, it's free and open source. If you have more than 250 employees, if you are making more than $10 million revenue, then it is not free for you.
Got it.
Yeah, means they have enterprise edition.
Okay, okay.
It's a free and open source. Anybody can use it. You just install this Docker, try to pull some image and try to run your own containers. So in the next session, I'm going to teach you Docker commands. I'm going to teach you Docker commands. I'm going to
Yeah, since you have pulled it in easier way, like it just there was a single click option for you, but you told DevOps engineers will use a command.
right, right.
So they'll use Linux.
You're right. Linux machines.
So they will Linux machines, or for example, if you have created something on Ubuntu, so we'll use the Ubuntu terminal and pull from Docker, is it?
Right, right, right.
Okay, okay. And one more doubt I had, if you selected something called 90 and 80, right? Can you just tell that again?
Yeah, sure. So you see, my container Nginx by default runs on port number 80, which is inside the container. Okay, so what I did, if I don't map it, I'll not be able to access from my local browser. See, from my local browser, I'm able to access my application, right? Here, see, port number 90. From my local browser, local host, port number 90. I'm able to access this. Just because I did port mapping.
Just a minute. How do you get to know your host is port number 80 or 90?
See, this can be anything.
Same question even.
This can be any port. See, in your laptop, there are 65,000 ports. More than 65,000 ports are there. More than 65,000 ports are there. You can run on any port, this port. But this is your application port, right? So as of now, like we have been working on industry, we know that it runs on which port. When you're running a container, it will automatically show which port number it is. Okay, this is the container port and this is your laptop port, your machine port, right? This is where our application is running. So this is 90 in real time, which what I used. This is 90, this is 80. By default, Nginx runs on port number 80. If it is SQL, it runs on port number 3306, 3360 or 06. If it is Jenkins, it runs on 8080. Jenkins.
So it picks automatically, right? The moment we try to configure, it picks automatically.
No, you have to mention it.
How do we get to know the port numbers?
It is there in Docker file. So when you write a Docker file, you will get to know.
Okay. So going further, we'll get to know that.
Yes. If it is a node applications, so developer they'll write the readme file. In readme file, you will get to know. Okay, this application runs on 3000, or it runs on 5000. It runs on 8081. You will get to know.
Got it.
So now this you can map to any port of your local machine so that you can access it from your local machine. If you are not mapping the port, you will not be able to access this application. You will not be able to access from the browser.
I didn't understand. Can you come again?
If you are not mapping the port, if let's say you are not mapping this to this one, you are not doing this.
80, number 80. Okay.
You are not doing this, you will not be able to access this from your local browser.
Okay, understood.
Yeah. So going ahead, there are a lot of things to discuss in Docker. Just practice this and get back with your questions tomorrow. So tomorrow again we are going to continue this. Yeah, tomorrow same time again. Same, yeah. Tomorrow same time we'll connect.
Yeah, Darren, so when you're creating a code, for example, in my so when we are practicing tomorrow
Mm,
or today,
mm,
so I'll create it for blindly for 90, right?
yes.
Since I don't have the knowledge of
Yes, yes,
what
yes.
port number is exactly going to,
If you are
I'll do it
using
for 90.
if you are using Nginx, this will be automatically picked. You can use for 90. Yes, this will work. You can use 91, 92, 93, 94, 95. Any port. So now if you how to stop it, you know already, right? We'll go to Docker desktop.
Just stop.
Then click on containers. Stop it. Just stop it. These are all the containers. These are running just because of my Kubernetes cluster. Let me stop my cluster. Yeah. So because of this, my laptop is, see, 800% CPU utilization. Pa, 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 pa. See this.
Got it. So the companies will be using a premium version.
Uh, for Docker, it depends on the company. If company size is large, yes, they'll be using enterprise version of
So your
Docker.
company is using premium version.
Yeah, if it is a large company, they may use it, but most of the times you don't need to, buy it for free. Sorry, you don't need to buy it. You can use it for free of cost, not an issue.
So companies like Deloitte will have a premium version.
Yes, I guess
Yeah.
since they have
So
large,
it will be similar, right? Premium version also.
yeah, same similar, no changes.
Okay.
Yeah. So then, yeah. So I'm gonna stop it here. Then let's connect tomorrow and we'll discuss going forward. So yeah, I hope you're understanding.
Yeah. And tomorrow is Vakshata correcting or only you?